Bon après-midi, mesdames et messieurs. Buenas tardes, señoras y señores. Good afternoon, ladies and gentlemen. My name is Sung-Hoon Kim, and this is ICAO SkyTalks. Welcome to the 13th Air Navigation Conference. This is day 7, session 29 out of 29. For those who are here, congratulations, you get to see this live. For those who have missed previous sessions, I ask you to please go on YouTube and type ICAO SkyTalks, and you'll see the whole list of presentations we have. And I'd like to thank also our panels of specialists, industry specialists, as well as staff here at ICAO for all this information. Now, since the early days of mankind and womankind, we've always looked to the stars and wonder about what was out there. Just a little over a century ago, we had our first successful experiences going to the sky, and then later on to the moon, then to the stars far beyond. Now that we have the technology to reach into outer space at a much lower price, space travel has been open to the masses, whereas in the past, only government entities had the ability to do so. Now, here to talk more about commercial space operations and the possibilities that it brings, please welcome Yuri Fattah, Program Manager at the Air Navigation Bureau here at ICAO.
Thank you very much for the introduction. So this is the last of the Sky Talks, I guess, if it's 29 and 29. So welcome to outer space. Well, not quite, but originally, for those who are attending the conference, this was supposed to be an information piece before you discussed commercial space, but you discussed commercial space yesterday, so this is now an information piece to see if you said the right things. Okay, so as was mentioned in the introduction, there are many new ways that people are thinking of getting to space. We've got to be kind of clear about some things. The laws of physics are very simple. You need a lot of energy to get to space. Hopefully one day someone finds out a different way with less energy. But there are here, as you see, 4 quadrants. One that is vertical takeoff, vertical launch. One that is vertical takeoff, horizontal launch. And then 2 separate ways of doing horizontal takeoff, horizontal launch. So in the top left, this has been in use for the last few days or last few months. People are now able to launch rockets up and land them vertically too. Then the bottom, you see something that looks like the space shuttle, but it's not, but it's a more advanced idea or version of that. Oops, sorry. So that launches on a rocket and it lands. The Sierra Nevada Dream Chaser is not yet operational, but they've been doing a lot of drop tests. Then on the top right, you see the Virgin concepts. They have a mothership. The mothership drops a spaceship, and the spaceship or the rocket goes up to space on a suborbital. And at the bottom, you have probably the most, the least developed of all these in terms of testing, and that is this dream of taking off like a plane, flying into space and coming back, the space plane concept. So while it excites a lot of people, aviation regulators get a little worried because we already have 1,000 objects to keep our eye on, and it's very difficult now. Someone who wants to go shoot up in the sky and come back down. So what we have started to do in the aviation community is try and better understand these. And here's an example of something that comes from our French colleagues, and they've started to do the ICAO thing, which is taxonomize, figure out what are the limited number of different scenarios that we're looking at. And so you'll see on the right there, we'll go through some of them a little more detail later. But if you look at the picture here of the atmosphere from about the ground and all the way up to about 350 kilometers, there's certain numbers that you might want to think of. The first number is that at around 50 kilometers, up to around 50 kilometers, where you see that that near space platform, as they call it, that balloon is at 36. About 50 kilometers is the highest level at which anyone who has a concept out there today, a balloon, a high-flying plane, is able to get to. So anything above that point, you pretty much have to be ballistic. You have to have a rocket. You have to be on your way up or down. At 100 kilometers, for those who are aware with the terminology, there is an ongoing debate between the great nations over in the UN about where the edge of space is. For physicists, it doesn't really matter. It's not like there's a line and you cross it. But when people need a line, for practical purposes, it's usually defined 100 kilometers, because at one point, some physicist, actually it was an engineer, von Karman, he decided that doing the calculations on air density, that at that level around, the air is so thin that you could not derive lift from the air. So in other words, you were in space. Why has it been a bit of a controversy for international scope? Mainly because there are space treaties that say that there is no country can claim sovereignty in space. So if you define the line of where space is, then the question of sovereignty comes in play. Having said that, nothing stops at 100 kilometers, because you have to get to 150 kilometers to be in low Earth orbit, which is LEO. So again, we have between 50 kilometers and 150 kilometers no one going there and parking themselves in that space. They're either on the way up or the way down. One day there will be, when hypersonics are flying around, but today it's not the case. So here we just see in very simple pictures, which hopefully kind of explain how this interacts with aviation, where it could potentially interact with aviation. At the bottom you'll see it says Class A, B, or C airspace, the top of which is usually around 60,000 feet. And then we put something higher airspace operations to get to that 50-kilometer line, and then everything else above is above. So we have concepts that is just straight up and down. These could land vertically, but basically they spend most of the rocket fuels at a certain point. They are just a ballistic object, which means they don't have any meaningful positive control. They're just on energy until that energy runs out because of the gravity of the Earth, and then they start coming down. The newer concepts have some spent fuel capability at the bottom to break their fall, but if you're an air traffic controller, you can see that telling this guy to turn left or right is not going to do much. Some cases they will go all the way up, and the difference between that little blue line and the big gray line, there are suborbital concepts out there that will never make it to space because they're just going on a big parabola. And the earlier versions, I think, of Blue Origin, they are not planning to go supersonic. They're not planning to go to space. SpaceX does. So here again, it's more for the community to understand that you may have rockets that are not actually space, that never get to space, but they're still rockets, right? Of course, at some point you reach such an altitude that you can then start deciding where on Earth you want to come back down. Physicists will take you on an endless debate with numbers, and they're probably right, we just don't have the patience to follow them, that there really is no difference between suborbital and orbital once you're able to choose where you're coming back down. But in terms of terminology, we still need to be careful because, like I mentioned before, suborbital is the only kind of concept that really bridges the aviation and space community, well, grays the aviation and space areas. So we have other concepts. This is like the Virgin one. I had to make the lower airspace a bit bigger here, not because I'm making it higher, but just so I can fit everything in. But basically, something flies up, it drops a rocket, and the mother ship, which is an airplane and certifies an airplane, comes down and lands. The other part goes up and comes back down. Now, I said the plane down there, the mothership, is an aircraft, but there are treaties out there that inhibit the transfer of technologies related to missiles and ballistic missiles. And these are very strict treaties. So we have a company, we're aware that there is a plane out there that can do this, and it was outside of its home state, and it was a regular 747 really, it required some maintenance, and normally the pilot would take it to the next maintenance bay and get it checked and fixed. But they were not allowed to do so because since it does this too, it's considered missile technology, and therefore it had to fly back to its home state to get fixed. So there are some interesting non-physics constraints here that we have to always keep in mind. Again here, this one shows more how when you have point-to-point transport, you have the international component. Now, international component is interesting some ways. In aviation, we never think, we always think of contiguous airspace. So you leave one airspace to get to the next airspace next to you. Well, when you launch a suborbital or an orbital that leaves one airspace, the airspace it's going to enter back into may not be right next to that airspace. So when they launch out of South America and it comes back over the Pacific Ocean, I'm not sure that those two, or maybe those two because it almost went around the world, but you might have a case where the two airspaces that need to coordinate things may not actually have a formal line of communication that we understand it to be. So there are a lot of headaches associated with introduction of commercial airspace and understanding how it's going to fit into our thinking in aviation. But two things. One, we know that we don't want to make the laws of man more insurmountable than the laws of physics. Right? We're not there to demand of science something that it cannot do. So we have to accept how these things perform. But the second thing is we have to understand also why people even want to go to space. And I think in this room, maybe everybody wants to go to space. Probably some people in their minds are there right now. But here are just some interesting things that our researchers have done. I've been able to dig up the research is actually done by others. What you see here on the chart is basically how the more people sign up to go to space, the cheaper it will be. This is standard economics. I'm not an economist, but the more people get interested, the more people sign up for Virgin, the cheaper it will be. We will never afford it. If someone in this room can afford it, please let me know. But it is a scale thing, right? People have used, now no one's got married in space. It says wedding and weightless wedding. That is in a parabolic flight, which is actually a suborbital flight. And that's where people got married. But you get the point. If someone's willing to do that, they much rather be doing it up in space. And then you see also the Falcon Heavy thing there. So for those who were able to witness what happened with the Falcon Heavy, but basically they're now able, if this happens to be a series of flights, they are able to really bring down the payload for heavy objects. Plus, if you really don't like your car, there's a new way to get rid of it. What you see here on the listing here, and I apologize if you cannot read it, but it says there are top 10 trips of a lifetime, and going on the Virgin experience is number 8. I was more interested in the other things, to tell you the truth, like dining through Paris's best restaurant. That's $10,000. Maybe you want to do that. It's the only thing I think I can afford on the list. Visiting all 7 new wonders of the world is $350,000. And renting a European villa is $100,000 a week, so maybe I could stay there for 10 minutes. But you see, this is the kind of area that's targeted. The space community has actually told us that these people known as high net worth individuals are just their capital to get into space, because there is no sustainability there. Most people who go to space on a private flight aren't going to sign up for another flight. And they would rather be doing all those other things on there. So that's not, space tourism as it's known these days, is not the sustaining part of the of the traffic, but it is it capitalizes the effort, right? It provides the investment. This is a complicated graph that really says a couple of things about how volatile this whole sector is, right? And we kind of know it. If you have a couple of mishaps, your prices really and your timelines, they stop becoming realistic. So there is a self motivation within this space sector to make sure that they don't have any mishaps. Because of the very first slide in the laws of physics, you're dealing with high energy situations. You know, the smallest mistake is a big explosion, so they have to deal with that risk every day. Another thing that this kind of shows is that there are, I think, about 400 or 500 satellites on the ground today waiting for a ride to space, large ones. And for smaller ones, it's a lot more, which means that people have already invested the millions of dollars to build the payloads. They're not going to wait and say, just leave it there. They're going to demand that the rockets that need to bring them up will be put in place relatively quickly. So the demand is there. The people have put their money in. The last two slides is more about, because I'm a technical person, I'm an engineer, but I understand and appreciate that there's a legal aspect to all of this that I probably should not be talking about, but I need to mention. So the last slide kind of will give you a feeling for what are these issues, these legal issues. This one kind of shows that if you're going up and down in aviation, it's very simple, it's very clear. You know, we've done this for 75 years, and we do it quite well. And then if you're in space and you're only in space, that's also okay. There are space treaties, there are things that make. But now we have these things that are sometimes an airplane, sometimes a spacecraft, and sometimes both. And it gets a little bit complicated for the business because they need assurance, they need clarity in what they will be held accountable for. And in that respect, we, one of the leading scholars in this area, I think Professor Dempsey, had, together with a couple of colleagues, come up with this kind of outline of major differences. So, not to put you to sleep here, but we have air law and space law, that's quite clear. For air law, we have aircraft. For space law, we have space objects. Aircraft are very well defined. Space objects are not as well defined. Basically, if you say that you're going to put someone in space, you're a space object. Of course, there's some level of common sense. It cannot be, you know, some ride in a fair that says space, you know. But I believe in some countries you get the rating of having gone to space if you go as high as 80 kilometers. In other places, unless you cross the 100-kilometer boundary, you're not given that designation. So in terms of sovereignty, this is also clear. We have the annex in the convention and then the space treaty. And that's, of course, a very pragmatic thing, because if you could extend sovereignty all the way to the black hole at the center of the universe, then you know, you have no positive control over that space anyway. So it's better to have a clean boundary. Liability is probably the most complicated matter. So the bottom line is that if you're an aircraft, you have all these protections through all the treaties and protocols. In the space area, the state that gave you the right to shoot, you know, go up into space and come back down, if that thing hits anything on the way up or anything on the way down, it's absolute liability. So it's not a question of getting an insurance company to underwrite you. You have to pay that. So one of the countries that probably most involved, the United States, they have passed their own national legislation so that there is a cap on that liability for the private industry, and the country takes over that liability, anything above it. Now, you can see that if you're a space company and you're like, wait a second, why can I just not be called an aircraft and get my liabilities protected? That might be part of the motivation. But that liability exists for a reason. There are not that many spacefaring nations, And until very recently, most of the space flights were state flights, right? They were government space flights, even if they were using private entities to operate. So the rest is more about registration and regular regulations. But the good thing about this side-by-side is that you don't have anything on one side that's not on the other side, right? So there is enough of an overlap between the different sectors. And what we tell our sisters and brothers in the space community, from the aviation community, is, look, we've learned lessons and we've had headaches, and we look forward to showing you how you might want to avoid the same as you become more international. What they're worried about, of course, is that we might decide that we know what they do and tell them, oh, why don't you just do it like us? We got 10 to the -9 safety records, so surely. So we have that open conversation. And hopefully as we go down this journey, the next time I deliver a SkyTalk, I will be a Skywalker. Thank you. Any questions? I hope not. Sorry, I forgot. Any questions? I got lots of answers.